Hey guys, alright, so for this video we are going to continue with 2.5. Okay, I just want to give you a heads up. 2.5, then the next unit will be 2.6. And after that we are going to have an end of unit chapter 2 test. So I just want you to be very aware that chapter test is coming super soon, okay? So before we start the unit or before we start the video, let's give you a toddler joke, alright? Here we go. What do you call a dog with a Rolex? What do you call a dog with a Rolex? A watchdog. Get it? A Rolex is a type of a watch or brand of a watch. Okay, so it's a watchdog. Ha ha ha. Alright, that is my toddler joke of the day. So in class, we have already done example 2 and example 3a, but we have not done is the check for understanding of example 2. So right now, I would love it if you pause this video, complete this check for understanding, and I will check it in class. So this is going to be on your own to see if you remember what this is. Okay, if you don't, you should look back at your example 2 and see how to do this. Make sure you box final answer, please. Okay. All right, so complete that on your own right now. Hit pause. Okay. After you have completed your check for understanding, we are doing example 3b because we have already done example 3a in class. So example 3b, let's read the directions. State the transformations. Okay, step 1. Then I want you to graph this function, f of x function, which is for currently 2 divided by x plus 3 plus 4. Then find the domain in the range of f. Remember, to find the domain and range of f, you would only need to find it on the last stage. Okay, you don't need to find it at every stage. So let me just quickly zoom in. There you go. Okay, because it's really small. I want to make sure you can see it all. So the first stage is going to be graphing the parent function. Okay, so the parent function in this case is f of x. You can also use y if you want to. And remember, the parent function is really an equation without any transformation. So this is a rational function, 1 over x. So that's what we have, 1 over x, without any transformation. And normally, I'm going to ask you to do the transformation from left to right. In this case, from top to bottom, and then left to right. Okay. I'm going to write all the equations out, and then we're going to come back as we go graphing it out. We will be also stating the transformation. The very first the very first equation I'm going to do is from top to bottom, so which is really 2 over x, okay, which is really 2 over x. The next one is I'm going to do, because I went top, so I'm going to go bottom, y equals 2 over x plus 3. Then my next piece is, remember, I'm going to go all of this here, y equals 2 over x plus 3, and then add the 4 at the end. And then as we are going along, we will come back and state each transformation. Okay. So this is your parent function. Make a input and output chart. Okay. Remember, we have an asymptote, a VA, a vertical asymptote at x equals to 0. So this is our line because x can never ever be 0. Remember this? Because x can never ever be 0, that creates an asymptote. Okay? An asymptote x equals 0. Label this piece. Okay? So x is 0, not possible. Not possible. Okay? So that will give us an asymptote. And then we are now, because we have one asymptote, we're going to have two curves, one on the right and one on the left. Okay? So I'm going to pick some right values, such as, let's do 1 over 5. Okay? Then I'm going to pick 1, then I'm going to pick 5. Okay? Just 3 inputs. When I pick 1 over 5, so here we go. When x is 5, 1 divided by 5 is 1/5. When x is 1, 1 divided by 1 is 1. Now here's the trick. When x is 1/5, 1 divided by 1/5, okay, 1 divided by 1/5. Let me just zoom in some more just for this first one so we can see what I'm writing. Okay. 1 divided by 1/5 is really 5. Okay. So because when you are dividing a fraction, you change it to multiplication and you take its reciprocal. So the output is 5. So let's plot those dots. 1/5 is super close to 0. Okay, I'm going to put somewhere between 0 and 1. So I'm going to go up 5 units. 1, 2, 3, 4, 5. Make a dot. When x is 1, y is 1. Then again, I'm going to go to the right 5, 2, 4, 5, and then 1/5. Okay, so now let's look at my 3 dots. And even if I pick more dots, like for example 10 or 100, when x is 100, 1 over 1 x, okay, which is x, let's just say that's 100. 1 over 100 is still just 1 over 100. So it's never going to be 0. Because y can never be 0, we also have this thing called a horizontal asymptote, okay, which is represented by dots or dashed line here. So we also have an asymptote at y equals to 0 and x equals to 0. So when you are graphing this rational equation or rational function, you would have 2 asymptotes. One's a vertical to indicate that x can never be this value. One is a horizontal to indicate that y can never be this value. It doesn't matter what input you have chosen or what input we choose. Okay, so connect my 3 dots. Okay, because darken the dots. Because y can't be 0, my right curve should not be touching either asymptote that I have drawn. Okay. All right, so the next one, let me get a different color pen to separate my left and my right. So that's my right curve. I'm going to go in and pick values by my left curve. Okay, left. And again, I'm going to pick negative 1 over 5. I'm going to pick negative 1. I'm going to pick negative 5. So when x is negative 1/5, again, I'll use my pencil. And you should really be using a pencil when you're writing notes, just in case I make a mistake, then you can erase as well. All right, so 1 divided by negative 1/5, we change division to multiplication and take its reciprocal. So my output is negative 5. Okay. And then 1 divided by negative 1 is negative 1. 1 divided by negative 5 is going to be negative 1 over 5. So those are my 3 outputs. Let's plot it. Negative 1/5 is super close to 0. I'm going to go all the way to negative 5. So 2, 4, and 5. That's my dot. Remember, keep in mind, I can't really touch the asymptote, so just put a dot in between 0 and 1. At negative 1, I'm staying at negative 1. Okay. And then at 5, 2, 4, 5, I'm going to go to negative 1/5. Okay. And whatever points you have chosen, those are the points you're going to have to stick with for the next few transformations. Okay. So this one equation produces 2 curves, one on the right and one on the left. Okay, next. My first transformation, here we go. Y equals 2 over x. This is the same as saying y equals 2 times 1 over x. Okay? Because when you have 2 on the numerator, okay, so if I wanted to, I can make 2 into a fraction. 2 times 1 is 2. 1 times x is x, so that will give me this. Because you are multiplying this, okay, by the 2, so we can put parentheses around that, right? It's really no difference. The transformation is called because the 2 is in the front, it's called a vertical stretch factor of 2. Okay? Because you have 2 times the parent. Okay? So that's 2 times the parent. So therefore, this is the vertical stretch factor of 2. Meaning that all of my y values will get multiplied by 2 times as much. So let's make a table again. I'm going to make a table right here. Okay. X and y. All the x values will not change. So again, because I have x at 0, that's my asymptote. That's still going to stay at x equals to 0. X do not change. This y will change, but what's 0 times 2? That is still going to give me an asymptote of y equals to 0, because 0 times anything is 0, so it's still going to be a 0 asymptote. Then the next value I'm going to use, I'm going to take all my outputs and multiply by 2 because it says it's a vertical stretch factor of 2. So here are my outputs. I've already used that for my asymptote. So the next output is 5. 5 times 2 is 10. 1 times 2 is 2. 1/5 times 2 is just 2/5. Okay, so that is my right curve. I'm using a different color pen for my left curve. -5 times 2 is going to be -10. -1 times 2 is -2. -1/5 times 2 is -2/5. Okay, so let me just extend this really quickly. Okay, all of my inputs, they do not change. Again, when x is 0, that's not possible, so that's my asymptote, so I don't have to worry about it. The next one is 1/5. That does not change. The 1 doesn't change. The 5 does not change. And then my left curve, -1/5, doesn't move. -1 doesn't move. And -5 doesn't move. Okay? So because the vertical stretch, meaning I'm going to change my y, so only the y values get to change, or in this case, multiply by 2. So let's plot your dots. So when x is 1/5, which is between 0 and 1, I'm going to go to 10. See how the difference, that dot is now up further? When x is 1, I'm actually going to go to 2. See that dot is now twice as much versus over here. When x is 5, I'm going to 2/5. Even though you're not going to see a much of a difference on your grid, on your graph here, but if you look at the value, 2/5 is twice as much as 1/5. So when we go to 5, 1, 2, 3, 4, 5, it's still a dot in between 0 and 1. Okay? But because we are limited on paper, but if you look at the value, it is twice as large in terms of the y values. Okay, so that's my left curve. My right curve, when x is -1, I'm sorry, that's a right curve, left curve. When x is -1/5, is between 0 and 1 still. I have to go all the way to -10, which is different. Remember how this is just at 5. When x is -1, go to -2, which is again different. This used to be -1, -1. When x is -5, go to 2/5. So 1, 2, 3, 4, 5, 2/5. Okay. So again, your curve should not be touching your asymptote right now. It's just going to be very close to it. Okay, so that's your left curve and right curve. I'm going to give you a second to copy that down, and if I'm going too fast, please hit pause. There's no shame in that. Okay. All right, next over here, moving on over. So the next one, we have already done 2 over x. The only piece now is the x plus 3. So if you really wanted to, you can go and add parentheses there. It doesn't really matter. It's just meaning that I'm going to do my denominator first, which you would have to. So because I have an x plus 3 on the inside, this is going to be a translation of a left by 3 units. Okay, I'm going to go left by 3 units. So what is that going to look like? If you're going left by 3, then that means this asymptote is going to move. So let's move that. 1, 2, 3. Okay, so now you have an asymptote. Instead of 0, it's actually at x equals to -3. If I'm going left, it's my horizontal moving. What if I take this line and move it to the left? It's still on 0. So this piece doesn't really move. And by the way, in your homework, because you do have a pencil and your x-axis is also a pencil, you can just notice how I'm doing like this line right underneath it. You can do that, okay? So that way I can see it. So right now, the only thing that's really moving is just this line, okay, until we make our input and output chart. So here we go. Input and output, okay? Because you're moving left or right, the y's do not change. So I'm just going to copy the y's over. 10, 2, 2/5. That's my right curve. -10, -2, -2 over 5. Okay, so those are the outputs. Let's look at the inputs, okay? So let's do some scratch work. I'm moving left, so I'm really going to subtract. I'm going to take 1/5, take 1/5. I'm sorry, positive 1/5. Why am I writing -1/5? Take positive 1/5. Okay. I'm going to minus 3. That's what you are doing when you are moving left to right. Moving left means you're going to minus. Common denominator tell me, okay, that used to be a 1, but I'm going to go in and multiply this by 5. What I multiply to the bottom, I also have to do the same. So this is now 1/5. Take away 15 over 5, which is really negative 14 over 5, which that is in mixed number. Let me move it over, you can see. So in mixed number, that's really 3, negative 3. Okay, so, I'm sorry, not negative 3, because negative 2, and the remainder is 4 over 5. Okay. So 1/5 take away 3 is going to be a negative 2 and 4/5. So negative 2 and 4 over 5. All right. And so next, you're going to take 1 and you're going to move the left by 3. So that means you subtract. So 1 minus 3 is going to be negative 2. Then we're going to take 5 minus 3 is going to be positive 2. So those are my right curve. Then over here, negative 1/5 minus 3 is now a negative 3 and 1/5. You get a larger negative. Negative 1 minus 2 is negative 1 minus 3 is going to be a negative 4. Okay, when you minus two numbers, you get a larger minus number. Negative 5 minus 3 is going to be a negative 8. So those are the 3 points I'm going to use to plot. Okay, ready? Negative 2 and 4/5. So here we go. 1, 2, negative 2 and 4/5 is between negative 2 and negative 3. Go all the way to positive 10. Okay, notice how the y values don't change. It's still the 10 on the top. Okay, and then I'm going to have negative 2 comma negative 2 is negative 2, I'm sorry, positive 2, negative 2, positive 2. Okay, the y values, again, don't go anywhere. Positive 2, okay, positive 2 comma 2/5. So here's positive 2. 2/5 is in between 0 and 1. So I'm going to invade. Remember, we're not going to touch your asymptotes, so leave it alone. Okay, and that's my first curve on the right. The second one on the left, it's going to be negative 3 and 1/5. So here we go. Negative 1, negative 2, negative 3, negative 3 and 1/5. It's somewhere in between negative 3 and negative 4 and go all the way down to negative 10. Ooh. All right, my light just went off because I'm not really moving. Okay, there you go. And then we have negative 4 comma negative 2. So negative 4, negative 2. Then we have negative 8. So let's count 3, 4, 5, 6, 7, 8. And I need to do negative 2/5. That means it's in between 0 and 1. Okay, so, and then try not to touch your asymptote. Okay, there you go. That is your second transformation. Okay, but I have 3 graphs already because the first one is always going to be your parent. So if you need to pause so you can finish writing, you need to stop and finish writing. Otherwise, you're not going to understand anything here. Okay, let's move on to the last transformation, which is y equals 2 over x plus 3 plus 4. Because you have an addition of 4, it's not a stretch, it's not a compressed. Okay, it's either left or right or up and down. And the left and the right is always with the inside, with the x. Okay, because this is on the outside, which is simply going to move up by 4. So that's my transformation. Because I'm moving up by 4, well, obviously up and down, that's going to be a vertical change, be a y value change. So look at this right here. This is my asymptote, horizontal asymptote at y equals 0. But because I had to move it up by 4, now I should have a horizontal asymptote at 4. So 1, 2, 3, 4. Draw a line. Y equals 4. Okay? And because I'm not changing my x, so I still have a vertical asymptote at negative 3. 1, 2, 3. So currently, this is what you have. X equals negative 3. Okay? I'm not going to use these, so I'm going to use them to make my table. Remember, I'm always going to give you a set number of coordinate planes. That doesn't mean you need to use all of it on your test. So here we go. X and Y. Okay. because I'm moving up for this last stage, the x's don't go anywhere. So I'm just going to copy my x over, which I'm going to move over a little bit. Okay, so here we go. Negative 2 and 4/5, negative 2 and 4/5, negative 2, positive 2, okay? And then my left curve, negative 3 and 1/5, negative 4, and negative 8. So those are my x values. It does not affect when I'm moving up, okay? Then 10. If I'm moving up by 4, that's now 14. I'm just going to add 4. 2, if I'm going to move up by 4, is currently 6. 2/5, add 4. That's 4 and 2/5. Okay? Negative 10 plus 4, that's going to be negative 6. Negative 2 plus 4, that's going to be a positive 2. Okay? I just want to make sure my addition is correct. 4, I'm sorry, negative 2/5 plus 4, that's a positive 3, and then we have 3/5. Okay? Because you have a 4 and then you have a negative, a positive and a negative will give me a positive number because this is larger, and then it's like subtraction. Okay? So these are my values. Here we go. Let's plot the right curve. Negative 2 and 4/5 is in between negative 2 and negative 3. And I have to go all the way to 14, so I'm going to extend this by 4 tick marks. Ready? 1, 2, 3, 4. So let's just make a dot right there. Okay? Right there. Negative 2, comma, positive 6. 2, 4, 6. So there's my dot. Positive 2 and 4 and 2/5. So positive 2. This is 4. 4 and 2/5 is in between 4 and 5. So make your best dot. Just connect them all. I'm just going to jump over there, make those arrows. Okay. Alright, so that's my right curve. Let's go on and work with the left curve. Negative 3 and 1/5. So this is negative 1, negative 2, negative 3. Negative 3 and 1/5 is in between negative 3 and negative 4. And go to negative 6. So let's go. 2, 4, 6. Okay. Negative 4 and positive 2. So we're going to go negative 4. 1, 2, 3, 4, positive 2. Then we're going to go negative 8 and positive 3 and 3/5. So negative 8, positive 3 and 3/5. And again, if this is going too fast for you, just hit pause, especially if you just want to try it out on your own, and then come back with a pencil, and then come back to see if you can check it, right? Okay, so notice how I have 3 transformations. One parent graph will give me a total of 4 different graphs. Now it says find the domain and range. So the domain and range will always be just one answer, one domain and one range. And it needs to be on the final graph of f. Okay? So it says find the domain and range of f. And this is f right here, this entire piece. So find that piece. So if you look at it, the domain is pretty much just going left forever and it's going to go right forever. Except in the middle, it doesn't have this value. Okay? And we also know the domain and range is always all real numbers unless we have a denominator. So we have to exclude this value right here, which is x plus 3. So we take that, we set it equal to 0, we are going to exclude negative 3. Okay, so all real numbers excluding negative 3, because when I put negative 3 back in here, it's going to give me a denominator of 0, which I can never, ever, ever have. All right? Let's look at the range and look at your graph. Usually the range, you do need a picture or a graph to do it. So a range looks like it's going to go down forever and it goes up forever. Except somewhere in the middle, there's this horizontal asymptote. That means I can't have this value. So the range is going to be all real numbers, not including positive 4. Because it doesn't matter what you put in for the inputs, y would never turn out to be 4. So those are my domain and range, and I'm going to box it up. And that concludes our video notes for today. All right, until next time, adios.